All right, hello. How's it going, everybody? Hello, Rasmus. How are you? Good to see you. I've been looking at your trains on the Discord lately. It's been fun. All right, I want to start a little bit. It's a workshop. We're gonna be darting around doing a bunch of different projects here. I got 9 million projects to do here. Save some of the Lewis stuff for while I'm on the road because I can do that. One thing I want to kind of play with is want to kind of make a power plant for a new helicopter and play with that. So let's start doing that. Let's see. So I want to kind of screw around with this. I want to kind of make a heavy lift helicopter. I've been wanting to do that for a while. Kind of have a design in my mind and use it in career and everything else. So I'm playing with that. Thinking fuel, outboard fuel or inboard fuel. We'll go inboard and then something like that. What kind of squared up? Kind of doing like a futuristic kind of look on this. So. Okay. Try something. How's it going, Sergeant? Good to see you. Watchable building, yes. What you building? Starting to work on. I'm trying to do kind of like a futuristic. I want to do the panels and kind of get like a kind of an interesting futuristic kind of heavy lift helicopter. So I'm kind of working. You know, I've been trying to do some power plants and everything else, trying to get set up for making some modular systems that I can utilize for a bunch of different stuff. So that's kind of what I'm trying to do. I just want to sharpen that back up again, but I don't know. I kind of like it. Round it out. So kind of the thought is it's going to be pretty much a cockpit, engines, rotor, kind of almost like a sky crane, but it's kind of the plan is going to be shit, can I get that in there? Not really. Kind of sky craney, but I want it to look different. I want it to be very squat. So for now, let's just fill that in, and I'll deal with that later. And then this is going to be for thrust correction, so when it goes forward, because I need to do thrust correction for the center of gravity, so I can tilt these nozzles so they're keep the center of gravity in line. All right, and then the general cockpit here is going to have to be, let's see, I want it, we got a 3-wide seat. So if we have a 3-wide seat and then a panel on either side, and then, because it's just going to be one person in there, maybe a jump seat. So 3, 1 on either side, and then 1 on, because I want this helicopter to be kind of compact and just like really compact package, heavy lift. So I think that's about where I want the engines. Okay. And one thing I've been doing, which I'm trying to do more of, is I want to use the pressure update to do simulated hydraulics and stuff. So essentially what you're using is you're using the pressure off of the fluids to be able to, for example, run anything hydraulic. If you don't have hydraulic pressure, you can't run the hydraulic systems. And so So I'm trying to like work the power plant first, and then part of it is adding on things like I might do different cockpits for different builds. So I kind of want a heavy lift module going here. CG's right about there. That looks good for CG. And then it's going to go further forward and aft with tail, but I can also work the weights, so. And then I want to do fatty ass rotors, so I'm going to do the large ones. And it's be counter rotating. Checking height. That height looks pretty good. I don't like 4 blades. 5s are... Nah, we'll do... 5's alright, I guess. That's kind of... I'm liking that. Alright. Yeah, that should be pretty good. That's kind of the footprint. I want it to be kind of on the smaller end like it is. I like that. All right. And so like I said, I'm trying to make this kind of a modular system that I can put this power plant on other things. And I'm trying to do that more and more with my builds lately just because I don't have a ton of time to play. So if I can make things modular, it's much, much easier to be able to get moving on shit, so. See if I want the sharp. I'm thinking sharp might look alright. Yeah, I kind of dig the sharpness of it there. So I want to get all the physical attributes that need to be in here, all the mechanical elements plumbed in correctly. Again, making this some modules so that if I want to build more stuff, or when I want to build more stuff, I can just do it. This would be kind of the module of it. Want it to look industrial too, so I'm trying to get some, like, put some industrial elements in it. Kind of like it's a construction vehicle for the air. All of the 2x go, or 4x right there. All right. Hello, Daniel, Christy. How are you? Hi, Jay. How are you, Jay? Good to see you. I'm kind of digging on that. Once it gets faceted, it'll look all right. Trying to think what I might do is this is looking too straight lined. I don't know about the facets. I'm not sure. But we'll put them on there for now, and don't want to take them off. They're easy to take off. They're just cosmetic, so. All right, let's work the mechanics of this sucker. All right, so that is where all the mechanical components will go in. Good bit of space here in the center. Hello, CG. How are you? Good to see you. All right, good. So that's in there. That can go. That can go for now. That can go. Nice, nice. That needs to stay. All right. All right, so we've got a lot of the mechanical elements going here. I need to find where this is. That's right there. All right, good. Yep, stop that. All right, what's that? That needs to go. That needs to stay. All right, that's good. That can go. All right, good. So we got a good bit of working space here to put a lot of systems in. He's a lurking. Good. All right. All right, that's good. I want to try a rotor brake, so let's save this real quick. Let's see. Coax, kilo, power, unit, module. Say 21. All right, there we go. All right, so let's go ahead and we'll do this. is. Alright, so it's in break now. I should have infinite electricity on. Pretty interesting to move one of them, I think. That's probably my problem, moving both of them. Let's try and make compact rotor brake. Let's see. Yep, how's it going there, Rakai? How are you? I'm trying to do a rotor brake with the looped gearboxes. Make it compact. See how it breaks it. So, it's a rotor brake is what it's for. Because they're moving in opposite directions, so it instantly screeches it to a halt. So that's what I'm doing. Just setting up a rotor brake. Alright, good. So that's set up. Rotor brakes on there. Rotor brake will probably go pre-clutch, I'm thinking. Yeah, so let's do this. Yeah, I'll do pre-clutch rotor brake. Because I've done this before in some helicopters, so once it gets airborne, they had this, I don't think they ever made it happen, but it was essentially a helicopter where the rotor blades would stop and act almost like wings when it was in forward flight, so they weren't spinning. And I've done that before, and I kind of like that as an idea of when you're in forward flight, it stops moving. So I'm going to do that. There's my rotor brake. I can do a wheel, but I'm trying to get away from that. That's goofy. Alright, so there is the rotor brake set up. What happened there? Oh, I shut off symmetry. God damn it. Alright. All right, good. So that's set up there for rotor brake working. Fuel lines, where do I want to run those? Yeah, one gearbox is set. So let's look at them real quick. So if you follow the flow, right, you're going to have power going this way, power going this way. And then it's 1, 1, 1, 1. And then one of them is just going in reverse. So it's passing the power in a loop through. And then you're just making one go backwards. The power comes and it tries to reverse. And it just stops it dead. I might put in a clutch there to slowly do that. I don't know what I want to do yet. I might put the brake. I think that's what I'm gonna do. I think I'm gonna slide it back here and put the clutch there, and then these will declutch when the rotor's stopping anyway. So let's do that. Cut you there, put you like that. Grab my rotor brakes. That way, because I don't want them to stop in an instant. I want them to stop slowly when it transitions to essentially forward flight. Okay. And so this way I can apply the, so these will clutch out and the engines will disconnect from the rotors first, and then it will gently apply the rotor brake with that clutch. So all right, good. It's not that big. It looks big, but it's not really all that big. I'm trying to keep it compact. Like you can see how it's not that big compared to me, but it's trying to be a heavy lift helicopter, so I want power out of it. So, all right, let's see what I want to do here next. It's just from the tutorial, just so I have something to start with. I'm trying to redo a lot of my microcontrollers here, so. All right, we have the throttle p-value there. RPS. Starter values in. Automated start stop clutch. Enable the clutch. That's clutch in there. All right, we can work with this. Make that kind of the basis of the panel. All right, that's good. What is a compound helicopter? Fuel would be nice, huh? What do you mean by compound helicopter? I don't know what you mean. What the fuck? No composites on this, right? What's that? That's throttle? Oh, I need throttle from here. This is old, and I would do it differently now. So let's say, why that side's not. Bitch, do not. Bitch, do not. Don't need that shit. Let's see. Thrust spoiler, it should be 1. Why the hell is this side over there not doing shit? Let's see. Alright, let's take some chat. It's gonna not gonna really vector there. It's just that's just a center of gravity correction. Is all that is. What it's gonna do is the center of gravity correction is all the tiltable nozzles are. I'd rather have straight nozzles, but I need a center of gravity correction, likely, especially with heavier loads. So I need to be able to tilt the thrust of the jets. And so it's going to be pushed by the jet thrust. Alright. That's good. don't know why that other engine's not running. I gotta look at it. Alright, you are, in fact, jet fuel. That is good. Alright. Why are you not running? The two of them are frickin' identical. Let's see. Merged up, piped up. Merged up, piped up. Merged up, piped up. There, merged up, piped up. That is plumbed. That is plumbed. All plumbed. I don't know why. One is running, the other is not. Yeah, I don't know what the deal is. Alright. What I do with Night Owl is I can run it on one engine or two to save fuel. So if I'm doing, like, say, traveling, I can, and I don't mind going slower, I can shut down one engine. And they're interconnected, and then saves me a bunch of fuel, too. So I think I'm going to do that as well. Will it fly? Yeah, I don't know why that side over here is not. Oh, because I know why. I didn't copy the microcontroller. That's why it's fucked up. Okay, that's what it is. I fixed one of the microcontrollers. I didn't fix the other one. I get you. Which one did I fix? This one. All right. That's what happened. All right, that makes sense. As usual, it's a me problem. You know, sometimes it's a game problem, but usually it's a me problem. It's like, it's one of the reasons I get annoyed when people immediately jump on, oh, it's the game. It's like, half the time or more, it's something you've done. And it's like, the cool thing about that is you can fix it. You know? Because you did something wrong. But people immediately want to jump on, it's the game. It's like, no, most of the time it's going to be something you did that screwed your build up. And that's what happened here. Yeah, I don't do tooltips. I don't need tooltips for that. It was just a microcontroller issue. Ah, there we go. That's up and running. I don't know how I like the industrialized look on the engines. I think I'm gonna take all that shit off of them, streamline it out a little bit. It looks weird. All right, so that's working. All right, nice. All right, let's see. The other thing, this here is gonna get, so IRL. They don't use inverted engines. They do it on like some training prop planes, because you have a critical engine. In real life, they don't do that. Well, for most, especially commercial applications. And what I mean by that is like Piper Seminole will have one engine turning one direction and one prop turning one direction, one prop turning the other, and the engines are inverted. That's good for training, so you don't kill a bunch of students. But it's not great for economics. So once you get like professional pilots flying commercial vehicles, both engines are, for the most part, identical, because if they're not, you have to have double the spares. And so you imagine, like, if you needed 3 spares per helicopter, well, if you had 2 different engines, now you potentially need 6 spares. You know, so you got 6 spare engines. And now if your left engine goes down, you eat up your left engines, and then your right engine, so you got a big stack of them that you've already bought and paid for. So it's prohibitively expensive. So generally, they don't have one engine turning one way, one engine turning the other. I might square the fronts. I don't know. I'm not going to go too cosmetic right now. That stuff can all be done later when I kind of figure the rest of the look of it. But yeah, I don't like all that shit on there. It was an interesting thought, but I can't do like half blocks. So I'm just that whole rant there was just for the intake fan should be turning the same direction. You know, like on the jet that I fly, and most commercial jets, pretty much all of them. Both engines are identical, so a left engine can be swapped out with a right engine, vice versa. Especially there's certain things, like for example, we taxi around on our right engine most of the day to get out there. So our right engine gets a lot more time than our left engine. So they could just swap them out and even them out at some point if they wanted to or needed to. All right. That's a little bit more sleek looking. Yeah, 1x1 jets would be perfect. And the reason I think 1x1 would be the size to have is one for the compact nature, so you could do APUs and whatnot. But also 1x1 jets, when you put a shell around it with enclosed piping, it would still be 3x3. So the problem is we have a 3x3 footprint that turns into a 5x5 footprint to put engine cases on. If you had a 1x1, you could have a it would turn into a 3x3 as the smallest, and then you could still have engine fairings on it. All right, so that's looking good. All right, so that's up and running well. So like I said, I'm trying to make a lot more modular stuff to make my life much easier. Alright, so let's change these up here. Shit, what's standard? Standard's 10%. 10%. And let's make 5 rotor brake. Yeah, it's not gonna work right now anyway, but that's fine. Alright, pitch. Roll. Yeah. Okay, that's good. Let's see. Trying to think what I have to. Let's do this. Stop. Let's see where we at here. I put them all in here. Look at dope. Where the hell is that going? There it is. Just make a new controller, frankly. Let's just do this. This will be easier. C engine RPS starter. Air manifold, fuel manifold, clutch, coolant pump, alternator, battery, panel. All right, that's good. All right. Upper collective, step collective. You can tell when it's one of my tutorials because everything else all you can see all the lines, and then I load that later and I go in and I fix it like this, so I don't see everything like that because I can't stand all my lines being diagonal because I'm a sick person, so I need to come in and do this essentially. So that looks good. All right. Let's see. Filled left, filled right, filled left, filled right. All right, that's good. That's where we want it. All right. Stab collective. Upper collective. Stab yaw. Keep an eye on what's that. That is lower collective. All right, what's that? That is upper roll. I'm just using one of them for roll. I don't need two. I don't need the power. One is plenty to roll out. So. All right, let's see. Center of gravity is just bonered at the moment, so I gotta fix that. Where's the CG right now? CG is a touch forward. How's that looking? That's looking better. Pitch isn't doing enough. What's up with my pitch? Oh, I didn't hook up pitch, that's why. Alright. Pitch just goes into the rotors. It should go in either rotors fine or both. That's why I don't have pitch control. I didn't hook up pitch. That would do it. Alright, that's roll. That's fine. Alright, good. It's like, why do I have no pitch control? Because I didn't hook up the pitch. So. Would it not be getting a turn now? Not really. We have a no lift at the moment. Something up with that. Pitch is working. Check roll. Roll's working fine. Interesting. Pitch, I should be able to run one pitch too. I don't need two pitches. So let's see, because it's adding a lot of resistance doing that. So let's do this. Put it on one rotor works pretty well, especially the top rotor gives you it gives you more of a pendulum effect because the rotor which is doing the work is further away from the center of gravity, so the pendulum wants to sit more stably, falling straight down. What it was doing is there was too much blade pitch going on, putting too much resistance on the engines, and then it was taking all the power away. So again, this is just the power unit that will then, like, I'll put tails and other elements of it on there. And so is it Rasmus's, can you use just one for rolling? So no, here I'm gonna stop it, let it settle. All right, so just to put your mind at ease, that is the first time I've hit auto hover since we've taken off. Okay, this is auto hover off. Okay, this is with auto hover off right now. And you see I can upset it, right? Now I have to fix the upset, but because it's built stably, so this is all me fixing the upset. Okay, I'll put it back in unsettled, settled condition. So this is no auto hover on, all right? So, when people are like the gyro sucks, whatever, it's the reason why this is working. The center of gravity is right under the rotors. The center of gravity is low under the rotors. And so it's like a pendulum, right? The pendulum always wants to swing, so it's vertical. If I put the center of gravity right around the rotors, it would be less stable. It might be good for, say, an attack helicopter that can roll really easily. This one, when I initiate a roll, you see it's not that slow, but it's slower than if the center of gravity was higher, because that pendulum wants to naturally come back to the bottom, which is good for stability. And so now if I hit, so I'll fix it myself. All right, so that's me fixing it. Auto hover's not on. All right. Now let's upset it. And all auto hover really is doing is it's like centering everything out. That's all it's doing. So like people misunderstand what auto hover is doing. They run with their auto hover on all the time. And so then they complain that, oh, my helicopter, like watch this, I'm pushing forward. My helicopter is not giving me as much performance. Well, it's because the auto hover is actively working against you. And so if I shut auto hover off, which it's off now, you notice I'll be able to pitch down much more. I'm out of fuel. All right. I can pitch down much more because the auto hover is not fighting me. So they just don't, they're not understand what it's trying to accomplish. But you see the center of gravity is right under the rotors and it's low. So if you move the center of gravity up higher, you would greatly disrupt the stability of your craft. So can I do one here? Probably not without making it a pain in the ass. So like for example, we did this. So again, if you build your stuff fundamentally stable, it is going to want to be stable, and it's going to act in a stable manner. If you build it fundamentally unstable, it is not going to act in a stable manner. And that's what a lot of people don't get is, so many of these problems they'll blame the game. And it's like, no, it's like the way you designed your thing is not stable, and so it's not going to act stably, So like if I put an absolute shitload of weight, and I get that weight up high, so now you can see it's right around the rotor disc. It's gonna, it doesn't have as much pendulum to try to straighten it back out. So I can use, this is great for like the ability to quickly roll because I'm not trying to move that weight with a long lever arm. I'm moving the weight with a short lever arm. So I can initiate the roll really quickly. I can bring the roll back really quickly. But it's not inherently stable. It doesn't want to stay in a stable configuration. And so like they build airplanes like this, they build helicopters like this, depending on their role and their job. Like an attack helicopter, get that center of gravity closer to the rotor disc. For a something like this where I want to be lifting, I want this thing to want to sit stably the whole time. So that as the weight, and it's going to help because if we have the weight low being picked up with, say, a cable, that's a very long pendulum. The helicopter is going to resist any sorts of change in its current position. So like, we'll go up and now you can already see, so I'm not, so see how much less stable it is? It wants to roll really fast and it's hard for me to get it to roll back. And that's with the center of gravity right at the rotor disc. So I've got the auto hover on now. Let's go outside and we'll play with this. So now I can initiate the roll much quicker and the auto hover's on, so it's doing the work. Now let's take it off. I initiate the roll, watch what happens. It's gonna keep rolling, rolling, because it, that center of gravity is right at the rotor disc. It's not helping us to return to stable. All right, so we go up. And then I've got auto hover off again, so watch. It's going to keep rolling. It's going to stay in the position. It's going to stay in the last position I left it because it has a center of gravity that's at the rotor disc. Now, if we move the center of gravity above the rotor disc, it's going to make it want to be upside down. It's going to prefer to be upside down than to be right side up. And that's obviously not a good situation. So again, a lot of these issues people have are because of inherent instabilities that they're putting in their builds. And I say the gyro sucks. The gyro doesn't suck. You can see, like, I'm flying it without the gyro, in auto hover mode, and it's fine. The issue becomes they expect it to fix all of their errors, and that's not, it can't do that. The ones you get on the workshop, yeah, they're working overtime to fix your errors. Or you could just make your craft inherently stable, and then you don't have to worry about that, you know. All right, so now the center of gravity is very high. It's way above the rotor disc. You can see here, it's about as high above the rotor disc as it was low before. And so the prediction now is it's going to be much easier to roll into a turn. And if you noticed before, when I let go of the keys, I didn't really say when I was letting go of the keys. When I let go of the keys, it would roll until I let go of the keys, and then it would stay there, and it would stay at that roll angle, and then it would just slide on the roll angle. What it's going to do now is when I let go of the keys, it's going to keep rolling because that center of gravity is above. And when we had the center of gravity below where we want it for this type of helicopter, it's going to naturally want to level itself out, and that's what we want. I probably got about another 45 minutes. So, you know, so much of this stuff is understanding essentially center of gravity and its effect on things. This works on cars and boats and planes and helicopters, and it's something that engineers have to worry about. All right, so I'm going to do auto hover on. It's going to be hard to control this one. It might not be able to get off the ground because of the weight at the moment. I got to gear up the rotors and everything else. Yeah, it's not going to let me get off the ground. It's too heavy. But let's see if I can get off now. It's too heavy for me to get off right now. But essentially what would happen is... I can't get up. So what would happen, like I said, is as we start that roll, it's going to keep rolling, keep rolling, keep rolling, keep rolling. And the way we had it initially, the way we want to build it, which is why I built it this way, is with the center of gravity nice and low, it's going to naturally want to not go out of control. It's naturally going to want to go back into control. And that's, for example, like airliners are built this way. Fighter jets are built the opposite. You roll, and you want to stay at the angle you rolled it at. In an airliner, you roll it, it wants to roll back to get it back to level. Especially training aircraft like that. So by having this down, and here, let's say it real quick. I'll show you real quick what I mean with this by loading in a base plate. All right. And you can see this really easily by going in here. We'll go in, we'll put in a pivot. And so essentially this is what's happening with aircraft and boats and everything else. And, you know, if you make something like, so this is the way we're going to make our helicopter, all right? So we're going to go ahead and we're going to make an equidistant post here, right? And I'm going to go ahead, I'm going to take off symmetry, and I'm going to make one end heavier than the other. All right. So this right end is heavier than that. So what's going to happen is it's going to swing down, it's going to swing back and forth, and eventually it's going to go straight up and down. And if I push on it, it's going to be less, it's going to, as I push on it, it's not going to be as responsive. It's going to want to get back to center faster. So there it goes. Now, you notice the center of gravity is not that much lower on the low side now, so it will have many swings to get back to stable. Okay, so now let's add some more weight to that one end. And this should stabilize more quickly because that heavier weight wants to be in the center of the Earth. All right, so with more weight, the swings should start to slow down, and we can already see each oscillation is not going as high as before because those weights really want to be at the center of the Earth. And they're doing everything they can to get to the center of the Earth, and that is slowing down the oscillations, and you're getting fewer oscillations before eventually it stands straight up. And so that's what this helicopter is designed at, with a low center of gravity well below the pivot point, which is the rotor disc. And that's going to make it so that, for example, if we start getting a container swinging underneath the helicopter, it's going to be easier for us to stop that swinging, right? So let's call that almost stopped here. And then watch if I push into it, right? If I push into it, right, it's less receptive to me pushing on it. It's going to not move as far. If it was lighter or if it was closer to the center of gravity, it's going to be more receptive to me pushing on it. So we can test that out by doing this. How many blocks? Let's see. I got to count the blocks here real quick. 7. That's about a character length there. 7. So now let's cut this and let's put it at the center of gravity right there, right? And we'll also move it down a little bit so that I can actually touch it. All right, so this is more like a fighter aircraft, right? So the So the center of gravity is closer to the pivot point, which is the rotor disc. And so see how it's like swinging almost 90 degrees? It's not straightening out as quickly as the one that has the long pendulum. And this is great for say a fighter jet or an attack helicopter that needs to be able to roll quickly, hold the roll, make the turn, roll out, roll back in the other direction. It can snap left and right and left and right and make the turns, and you know, that's what they're designed for. It's like, you know, that and like acrobatic planes. So when I hit it, I can easily get the same amount of weight to get moving up higher because it is right around the center of gravity, and this would be much easier for me to spin all the way around. The other one would be incredibly hard to spin around. All right. And then to do kind of the other one, right, is, I don't even know if I really need to even show it to you, but you cut this and you make it upside down like this. Well, I think we can tell this is going to be unstable, because if we say that this is upright, right, this is the direction we want it to be, is up, right? Well, we spawn it. Okay, that's great. It's up, right? That's up. Our helicopter is up. But the smallest little bit of disruption, and now it flips upside down. That's why you don't want a center of gravity above your pivot point on a boat or plane or anything else. Is it wants to roll upside down. And this is where people get their boats in game, where they roll upside down all the time, is their center of gravity is above their pivot point and it wants to be upside down. So you can see that's not desirable at all, right? And you'll see it would be even worse the further this gets away from the center, the pivot point. If we put the center of gravity way high, right, that is gonna, hopefully it won't hit the ground. It shouldn't. It's not taller than that. So that's gonna want to right itself, right? It's gonna be very unstable. So right now it's sitting fine, and there it goes. Ah, fuck, it hit the ground. I'm going to move it down 1. Should swing. But because now the center of gravity is further away from the pivot point, it's going to want to stay... it's going to more quickly stop oscillating. Let's put it that way. So it's going to want to right itself to go with the weights facing down, and it's going to take fewer oscillations for it to do that, because that weight's like, nope, let's get back to the center of the Earth. And every time it goes up, the swing is getting shallower faster, because the weight is trying to pull itself to the center of the Earth more, because it has that long lever arm. The longer your lever arm is, the bigger the pendulum. It's going to want to be more stable. So you can see that's why we're building our craft like that. The rotor disc is our pivot point. The center of gravity is our weights. The further we have it away, And this long lever arm, right, it makes it so that it takes a lot of force on the rotor disc to be able to lift this weight. We need a lot of force on the rotor disc to lift up this weight. And so it makes it more stable. It makes it less twitchy. And that's what we want in something that's going to have to do precision movement, like pick something up heavy, move it, say put it on a boat, put it somewhere, do a rescue, whatever. You want that inherent stability. All right, let's go read some chat. I have attack helicopters. I don't really do any stuff with that. Having two engines on a small aircraft can be bad if one gives up the sudden difference in dynamic maneuvers. What? I heard that having two engines, yeah, like a small twin. Small twin, you have to worry about VMCA, where if you go below the VMCA speed, the aircraft the light twin will roll upside down, and that's why they have counter-rotating props on things like Seminoles, is to prevent that, so you don't have a critical engine. So like, there was a saying they used to say with small twins or light twins that the second engine there is to get you to the site of the crash faster. Do you do roll with AD and helis? Yeah, why wouldn't I roll with AD and helis? Roll is always AD. It's a yoke. I push the yoke forward with W, I pull the yoke back with S, I roll to the right with D, and I roll to the left with A. If I was in a helicopter with a center stick, it would be push the stick forward, goes down, nose down, pull the stick back, goes nose up, push the stick to the left, goes roll left, and then your feet would be the rudder pedals. So my left hand is my left hand in the airplane, and my right hand is my feet. Yeah, I'm aware that you could do it 10 different ways. I understand you could do the rotor brake in different ways. This is the way I want to do it for my reasons. Your collective looking wild? What are you talking about there? Currently they're doing 60, but they're going to get geared up. It's just for testing here. There's no point in me finding out the gearing effect of it. All right. All right, so this is, let's go ahead and we're actually probably getting to that point anyways to gear up the rotor. So currently I want the rotor to go about 60. We can see if we can get higher, but 60 is usually pretty safe. The turbines are going 60. I've got them set there. They should have ample extra power on them. Let's go... I'm trying to think what we want to do for gear ratios on this here. I think 9-to-1 is ambitious. 9-to-1 is probably ambitious. I do it on most of my planes are 9-to-1s, but let's run with that for now. Alright, this is going to be dangerous as hell, but I got to look behind me. Woo! 60 RPS right there, right? Alright, so because it's above 60, see the jumping? You either need to decrease the sensitivity on the gyro. See how it's doing this? This is where you'll see this constantly, and people are like, my helicopter's acting the fool. It's like, one, your sensitivity's too high, or your rotor speed's too high, or both. So 9-to-1's fine. See how it's jumping around? That's because the gyro cannot react quickly enough because the rotor speed is so high. So you can decrease the sensitivity of the gyro, trying to get it down so it doesn't do this. Or what a lot of us will do is make sure our, see that's the rotor just going too fast. All right. So what we can do here is, we'll just do the math. What do I do? 9 to 1. So we want 60 or below. So we'll do 60 divided by 9 is going to give us 6.66 the devil for a max RPS. So that's generally what I'll do. So we'll do 6.6 there. That looks good. Spawn that. All right, good. So now this should help prevent that. Because it just like, and this is where people will go on the workshop to the gyro section, and what can they do in the workshop? They can more finely tune the PID, because that's all the gyro is it's a PID. And so we don't have as granular control as you could if you made one, right? You could change the I values, the D values. You could really get it tuned in the way you want. Now, or you could slow your rotors down. So there's, you know, a bunch of ways to do everything. So now right, it's math. As long as the turbines are moving at 6.6, and it's multiplying it by 9, it should keep it. Now, you see it's a little jumpy. That's because I'm pretty much working on just a p-value of 1. I'm not really fine-tuning my engine. So you see how it's not as crazy, but it's still acting up. So we can still knock the rotor down a little bit. So the rotor speed is likely still too high. But we're burning a hell of a lot less fuel. So the other thing we can do too is do this. Trying to think. Let's do that. Because we got a lot of power going for us here. And I want reasonable fuel efficiency. So that's an 18 to 1 if I do it 2. It might not be powerful enough for this. It probably isn't. I got to test it out. Let's see. 60 divided by 18. 3.33. Could have done that in my head, but we'll do 3. And I don't want to gear it up too much because if you remember, I said I want to be able to run it on one engine for like, if we're just moving from A to B, we can run it on one engine, save some fuel. And so we can run on 2 engines when we need to lift something heavy, or we're trying to go fast somewhere. All right, and I got to look at my rotor speed again. So that's 43 RPS. So as long as we stay below 60, we're doing pretty good for stability's sake. And that's just kind of a limitation of the stock gyro, because if I were to guess, if you were to rip that gyro apart and you went to the sensitivity setting, it would be doing essentially the p-value. What is the p-value of the gyro? And you change the sensitivity and it's changing the p-value. That's probably all it's doing. So we'll try changing the sensitivity too. I gotta see what the actual, I would say we're a little bit high on rotor RPS here. So one thing we can do to test it is just bring it down a little bit. Let's go down to 2. We'll see if it's still acting the fool at 2.2. Why are we just lifting up at the moment? Yeah, we are having problems. I gotta fuck with this controller a little bit. What do I have that has a jet engine in it that's working really well? Let's save this. Because what I'd say is it's my basic tutorial. It was very basic. It was just do a p-value of 1. So let's go in here and... I would say Night Owl is probably pretty well tuned. Let's see what that looks like. No, it's still running just a 0.1. Clamping at 0.05, max that. Yeah, I'm doing this even more simply than I should be probably. Up, down, counter 2 to 20 there. Range 2 to 20. Okay, so I don't need to probably tune that too bad. That's all right. Let's see. So that's not, it's not the tune there. I gotta see why. I gotta see what the rotor RPS doing. This is the other thing we'll do. We'll try this first before I start digging into stuff. It's probably not. Let's go in here. And let's go in, and these are all at 100%. Let's bring these down to 20s. Usually 100% is way too sensitive. All right, and I need some dials so I know what the hell I'm doing. Let's just get a simple RPS off the engine, and I can do the math in my head as we're rocking and rolling. All right. Music's getting loud. Why? What is going on here? I didn't have it up at all. Why is it even doing that at all? They shouldn't have even started. Oh, they should have started, but they what the fuck is going on there with my thrust lever? What's going on with my thrust lever here? Throttle? Throttle. What is going on? Why is it not responding to my... Oh, that's why. Oh, this is fucked up. That's why. Okay, this is fucked up. This is why we're having problems. I changed the way the system works. Before I was doing it with the up-down arrow keys, and so I was using this. And the problem now is this should be direct connected. So what it's doing is when it was hitting 1, it was going up to, just trying to go up to 60. And so it wasn't going where I was commanding it to, so I just need to do that. Okay, that's what was up. Because I was like, why are they maxing out? I haven't done anything. And so, okay, that's good. That should fix it. All right, that's all it was. All right. It was over revving it too, so. Now you see it's under control. So it should go up to around 3. There it is, around 3. And then it's good. Okay, so that's way too much, a 9 to 1. And the only reason it was starting before was because, or that's an 18 to 1. Yeah, see how it's going? So the clutch is killing it because it's, an 18 to 1 is too much. 9 to 1 we'll try. It was me screwing up not fixing that when I changed over to the thrust levers. The throttles. There'll be thrust levers, they're turbines, so. I need 6.6 now, though. I'm under on this. I should have fixed that, too. That's where a lot of people don't understand the whole thing with gearing is, you know, like somebody asked on Reddit, it wasn't in a stormworks thing, but they're like, oh, well, why can't we just, like, keep increasing gearboxes until we can, like, make infinite power? And it's like they don't get the fact that as you increase speed, it requires more torque. As you turn the gearbox the other way, you're making more torque with less speed, and so it's a trade-off. You know, you don't get these things for free. So you'll see this should turn the rotors, but it's going to take a big recovery time. And so one thing why this works is force is mass times acceleration, right? So when I was at 2.79 RPS on the turbines, the blades of the turbines, the compressor section, the turbine blades, the N1 blades, all those moving parts have mass. And so the faster you move them, the more force, right? The mass is the M of F equals ma, right? The A is the acceleration. A is the RPS. So you have two things you can do. You can make your engine heavier and turn it at that same RPS and make more power, or you can take the same weight of the moving components and you move them faster. And so at 2.79 RPS, or 2.73 or whatever we have now, it's only making so much power. So if we want to make more power, we can make the turbines move faster. And so that's why, like, you can't just gear up to the 1,000 to 1 gear ratio, or 1 to 1,000 gear ratio, because it's going to put so much back pressure in the engine. It's going to slow it down so much. You're going to lose and lose and lose so much power. Eventually, you're going to kill the engine. All right. So let's see where we're at here. All right, that's at 25. So I need about a little more than double that. Let's go back to 6.6 is probably going to work for us. No wonder that was misbehaving earlier. Let's see. So it's back to a 9 to 1. So 6.66 should hit 60. Giggity. All right, so now let's wait for this to get up to 6 something. All right, so there it's at 6.3. So we're moving the turbines, right? All the parts are the same. The mass of the turbine components are the same. What's changed is the speed has more than doubled. So we have more than double the power. And so as I put in the clutch, the mass of the rotors is the same, right? And so this should help turn it up. So you notice it didn't dive down to 0.5 where it did last time. And now, because we're able to spin our engines up to a higher speed, we're now multiplying that higher engine speed by 9, and that will give us the resultant rotor speed. All right, so you notice the rotors are now up at 6.28. Clicked on auto hover there before I died. And so now the rotor disc is moving slower than 60, and we shouldn't have that jumpy behavior. And so now I'm going to take off the auto hover. And so like I said, watch, I just tapped the A key and I let go of it. All right, so now it's reasonably inherently stable. I just tapped the D key, that's all I do. S key, I'll tell you what I'm doing as I touch S, 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 D. And you notice it's nice and stable, again, because of that pendulum effect. All right, so I'm controlling it now. I'm going to do a snap yaw. I'm going to pitch. I'm going to do collective at the same time. I want to do all the controls at once to make sure that we have enough power that I don't kill my engine. And if we look down in first person eventually, if I look here, I want to do all the controls, and you see how we lost 0.01. That's it. So I'm pretty well balanced on power now, where the problem is if you get it on the knife edge, every time you do a movement on the rotor blades, it's putting resistance on the engines. And if you have too much resistance, it's going to slow your engines down. You don't want them slowing down too much. And so as I make a movement, especially multiple movements like that, you see we went down 0.02 is it. So that means that we're pretty well balanced where we still have ample power. It's not going to start to, for example, fall out of the sky if I try to do all my movements at once. I want to be able to yaw, pitch, collective all at once and not have the helicopter want to fall out of the sky. I got about 15 more minutes I can play. All right, so let's get this in. So again, auto hover's still off. And so this is where people are like, oh, I always have to fly with auto hover, or my helicopter's unstable. It's, again, you're looking at where your center of gravity is, you're looking at where your rotor is, and if the center of gravity is nice and low below your rotor, it's going to be more stable, it's going to be less snappy, if that's what you want. If you want it more snappy, you're going to move that center of gravity up. But center of gravity should pretty much always be below the rotor disc. Or not necessarily. Let's put it this way. If you had, for example, a tandem helicopter, you would want it between the rotor discs, right? If the two rotor discs are equally powerful. If you had them four, right, you'd want it in the middle of all four. You want that center of gravity balanced out. All right, so that's good. Let's fire. I want to fire this up and see where we're getting to on RPS here. So I'm just gonna. I can multiply. What was it? It was 6.229. So 6.29 times 9. That's 5661 is the RPS. So we can go a touch higher, and that's because I'm using a simple P on the PID. So when I set 6.6, it will never reach it because the P value is too low. And so that's fine. Let's go 7, and let's see where it gets. So I'm happy if it goes up to 6.66. I don't want to go really any higher than that. So I artificially make it so that it always stays low, and that's just my method to not, because once you start where the p-value is high enough that it goes past your set point, it's going to dart back and forth, back and forth, back and forth, back and forth, and then you have to start worrying about things like I value and D value to balance those out. And especially when I'm doing the tutorials to kind of teach new people this stuff, it's like, if they have to now balance 3 different variables in the PIDs, it's just massively frustrating and confusing. And so it's better keep it simple, make it do a p-value that will never reach the set point, and you can artificially raise it above the set point. It'll be fine. Like right now, bingo, there we're just a tiny bit above 6.6. We shouldn't get too much instability. We're probably just a little bit above 60 RPS, but like you notice, we're not having any real issues here. We're probably maxed out where we want to be here. All right, there's the auto hover off. So now we can get our nose down more, right? Because it's not fighting us. And so again, like I said, I'm trying to make a module here where I can use this module on multiple helicopters. And if I want to change the rotors, I can change the rotors and everything else. So this is with the auto hover off, and you see it's flying nicely. I have good control over it. I can put it where I want it. It's inherently stable because of where the rotor disc sits in comparison to the center of gravity. Like right now, I'm going to stop us and try to get us to sit stably. That's it right there. Now I'm going to push a bunch of keys, but that's all your auto hover is doing, is it's constantly making corrections to try to get you to not move relatively. So like I'm tapping collective, tapping WS and A and D just to keep us sitting in position pretty much constantly. And when I hit auto hover, that's all it's doing for you, is it's doing it for you. You know, it's trying to make sure you don't go forward, don't go back, don't go left, don't go right. And so when you leave that on, I'm pushing forward, it's trying to fight me, and I let go. Now it's doing what it was doing the whole time. It's trying to get us to stop moving. All right, good. Let's take a quick pick. I need something for the new thumbnail. All right, you make that thumbnail. All right, good. Let's go ahead and do this. Let's take you back to the workbench. All right, let's do this. Let's save it. So I pretty much have the RPS dialed in. I have the gearboxes dialed in. I could probably add another gearbox with like maybe a little bit, but I like the dynamic nature of this. I don't want to screw with it too much. Let's go ahead and save. All right, let's do this. Find the CG. Right about probably there. Yeah, it's right under the rotor disc. That's good. Here's rope anchor. There it is. I literally didn't recognize sail anchor because I don't think it... I use sails a little bit, but barely. Alright, weight block weighs 10. That's 5. It's 5. Okay. Alright, 5 by 5 is 25 times 10. That's 250 a layer. There's 5, 750. That's going to be 1,000. That's 1,500 right there. 1,500 there. 1, 2, 3, 6. 1, 2, 3, 4, 5, 6. 6. Okay. Alright, so that's 1,500 bones on that one. Let's see. Kill that real quick. Alright, so that's 4,500 right there. This is a cool feature they added if you remember not too long ago, right? We can go ahead and take 4 and we'll hook it to the detached rope. So if we needed to in emergency, we can drop it. So let's go see if we can lift this. 4,500 should be more than a container. I'm also, I'm trying to balance a bunch of things with this build. I want to make sure that it is economical. I want to make sure that it, and part of the economical is I could probably make a really super duper heavy lift helicopter that that doesn't burn a ton of fuel if I did diesel. I would like to do it turbine. So you really get into an issue there with cost, and so jet fuel is expensive. So if I want to make this thing so it's actually economical on a career game, I have to make sure that I'm not burning too much fuel. I could throw 8 engines on there. I could do that spammy bullshit that people do where they don't have a compressor section at all. Yeah, like go try actually having a turbine engine without a compressor section. That doesn't work in real life. So I don't want it to be unrealistic either. So I'm kind of balancing some of these effects. I'm trying to think, should I add a winch? I need to get out of here, and I don't want to... I'm going to try putting it on wheels, or just shortening the rope up. Let's see. Let's lift it up and put it on wheels. So I could make this thing super duper heavy lift, but part of the problem that I'm trying not to do either is I don't want it to be where it's an 8 engine monstrosity that you'll never be able to actually make any money with. That really doesn't interest me. So it's like there's some cool heavy lift helicopters you could do with glitches and everything else. I'm trying to keep it realistic where the engines are realistic and it's also economical for a career game, so making it over the top is not what I'm looking to do. Because then it's no use to me. I just can't keep make any money with it. That's great. Go move a container. You moved a container that's going to make you 30 grand, and you put it on, you know, brought it over, but it cost you 60 grand worth of fuel. There's no point in doing that, right? The other thing we can do to, if we need to have more reserve power, is you would decrease the gear ratio and increase the turbine speed. That burns more fuel, so I think at around 7 RPS with 2 engines, we're staying around the economical range. So and again, this is just the module to put on the helicopter. It's not actually the helicopter. There we go. Just have to brute strength the shit out of here. It's like I didn't want to get over that lip. All right, so here is, all right, so now notice the stretchiness of the rope, right? Let's let that settle out. But as we were talking about before, right, you have the pendulum effect. Now we have something that weighs considerably more than the helicopter itself way below. And you can see how fast the rotors are trying to counteract the oscillations of that. But now, like we are talking before, the pendulum effect. All right, I took off auto hover. Now, as I make a turn, watch what the pendulum does. All right, and I go back to stationary. It goes back and forth, and this is going to be even more stable than the helicopter by itself. So let's start moving to the right. I'm going to hit auto hover. That's just going to put me in a stationary position. And now you can see the pendulum below the helicopter, just like in the test, swung back and forth a couple times and stopped because it's very, very low below the center of the helicopter. This makes the helicopter much more stable, having that weight low. And so we start it again, auto hover. Watch, see how it swings back and forth, and see how quickly it stops swinging. The lower that is, right, the more quickly it would stabilize us. And so that's why having the load nice and low below us is going to actually make us more stable. All right. So that's a good test there. Still feel dynamic, still feel like I can move around. Now the problem becomes this, and I'll show you. Oh shit, that fell out. Yep, like a pendulum with a pivot. Somebody on Twitch. I thought I was gonna not have to kick anybody on Twitch today. Apparently not. I'm gonna have to kick somebody on Twitch. It's always bots too. Twitch is just fucking inundated with bots. I should just not even bother. I'll just add a block list on Restream so I don't even see it. I'm so sick of like wasting my time reporting shit on Twitch that they're never gonna ever do anything about ever in the history of the earth. All right, let's do this. All right, so to kind of talk about center of gravities real quick again, I gotta go. But the one of the reasons, so let's look at the CG right now. Okay, so if we look at the center of gravity, it's fucked up because this is in the back. But essentially, it was sitting right about here on the rotor disc or on the build, and so it's right under the rotor disc. It's nice and low, and if you notice, it's also pretty much in line with the with these thrusters here. So if the helicopter is by itself, these thrusters should be able to point straight back and push the helicopter forward, right? And I'm trying to think. Let's do this real quick. I gotta go, but let's do this real quick. I didn't save it. I should have a pendulum around. I always, no. Anyway, so think of the pendulum again, right? If you have if you're pushing at something right below where the center of gravity is, it's going to impart a force on the body. And we talk about this all. I talk about this all the time with like why your seaplane is nosediving and not taking off. Right? There are a lot of planes that the engines are tilted for this very reason. I'll take a Lake Renegade. Is probably the best to show you this. Lake Renegade's really kind of interesting to show this because you can really see the angle of the engine tilted. And they do this all the time where they tilt engines of airplanes, and they're doing it to correct for the center of thrust not being in line with the center of gravity. And so if we go, here we go. So there's the Lake Renegade here. And so if you notice, the engine is way, way high above the plane, and that's because it's going to sit in the water somewhere around here. And you don't want the prop hitting the water. That's going to destroy your prop, destroy your engine, right? So you put it up high, up and out of the water, and it's because it's high, right? And the center of gravity is right around here. As you thrust forward, right, it's going to cause the, let's just do this. All right, so what's going to happen, right, is because you're, let's put our center of gravity block in here, and let's say it's the pinky color we use in game, right? So let's say your CG is somewhere around here, around the wings, right? That's usually where it would be, is right there, right? That's where your center of gravity is going to be. Well, what's going to happen? If your engine was not facing, if your engine wasn't angled like it is in this one, your resultant lift vector, or your resultant thrust vector, I keep saying lift vector, I meant thrust vector, is going to look something like this. So your thrust is right here, right? So that's your thrust, is pushing you forward this way, right? Or you could do it, thrust should be backwards. Let's do 15. Let's go like this. So your center of thrust, if the engine was not angled, it would push like this, right? And this is your point of rotation right here. So what would happen? It would cause the nose to go down, and so your resultant vector would be something like this. And so that's what you see a lot of the time in game with stormworks, is people build a seaplane, and the engines have to be up high so they don't go in the water, and they don't angle them with the propeller pitch component. And so what happens is, as your thrust pushes above the center of gravity, it pushes your nose down, right? And so that's a problem. And so if you look at the way the lake is set up, look at the angle of the engine. We'll go from the front of the engine through the nacelle, right? That's lined up, and we'll keep going down, make sure it's still lined up, still lined up, still lined up. Look at the angle, right? So the angle of the engine is back, and what that's doing is, instead of us having an arrow like this now, the arrow is more like that. And so then when you take off, you naturally, your nose, you're not going to be level, you're going to be nose up a little bit. And then what happens there? Let's look. You now have in cruise a thrust vector that looks like that. So even though the center of gravity is down, because we're angling down, that's accounting for the center of gravity to be at a different level. And so with this vehicle here, let's take a quick pic of it. Let's load it up. So essentially, that's why I have these tilting nozzles on here, and I'll show you in a second why I'm doing this. And then I'm going to finish up. All right. So the same type of thing is going on here, right? So we have our center of gravity block, and the center of gravity is right here. All right. And so that's pretty close to in line with the center of thrust. So our center of thrust is going to be right here, and it's straight. And because this is in line with the center of gravity, the resultant force forward looks like that. And so it's balanced. So I should be able to fly, and I should be able to open up the spoilers and go forward. But the problem becomes this. As we put weight on this, right, and now our center of gravity is going down. So let's say we're picking up a container, right? So what's going to happen with our center of gravity? It's going to go way down, right? So now center of gravity is low. Thrust vector is going straight back. And the nose is going to go pitching down. And so we're going to have a problem here where, as we're trying to more rapidly move cargo from A to B, we're going to have a nose down pitching moment, and we're going to have to use an up force on the rotor blades to keep the nose up, and eventually we're going to hit the maximum of the rotor pitch, and if the force is still strong enough, we're no longer going to be able to pick our nose up. And this is where you get people having problems where they're pulling back all they can and they're never going to get the nose up. And so what you can do is you can angle these, and so as the weight goes lower, we'll angle these down a little bit, and then with the new center of gravity there, it's going to readjust our thrust line so it's straight. And so what will happen is we'll be able to carry a heavy load below us, and we'll be able to go fast forward by angling these down a little bit. And so that's what we're trying to do there. And that's why I have these angled exhaust nozzles in there. And that's what's going to help us go forward a little bit faster. Now, what I would love to... Now, we can do this with propellers really simply. In the case of the Renegade, right, in game, we don't have to angle the engines, mercifully, of propellers. We can just move the pitch of the pitch component, and what we're effectively doing is the engine stays where it is, but the pitch now changes, and we get this this better angle. And I have to do that with these nozzles for jets, but what I'd like to see the devs do is we have the... And I should put up a feature request. But what I'd like to see the devs do is this. You know, it's all magic anyways, right? They can add this to the parts, and I think it would be kind of cool if we look at the ducted fans, right? We have these ducted fans, and what I'd like to see the devs add on the ducted fans is a pitch correction. And so what they could do is they could add a pitch correction node where, just like a propeller, you can change the pitch of the propeller. And so, for example, let's bring up my plane. I'm trying to find some images here. So you can see it. It's not super duper noticeable. I'm trying to find a good picture where you can really see the angle of the nacelles. Okay, so this one's a pretty good pick there. This one will work. All right, let's do this. All right, so let's bring this up then. Like I said, I gotta go. But so if we look at a jet, they do this as well on jets. So if we look at the engine nacelles, you can see the straight back of the jet. Look at the engines. The engines are angled up. All right, the engines are angled like this, slightly angled up. And so that's the thrust is now slightly angled, right? And so that's the angle of these turbines there. Let's find another one. I think a 175 has a pretty good angle on its nacelles as well. Trying to find a good side view picture of it. Some of them are really pretty extreme. You can see it. Others are harder to see. Yeah, it's hard to... Let me see if I can just find jet engine nacelle angle. See if I've got some pictures going on of that. Yeah, this one's a good one. But this is a Trip 7, looks like. No, it's not Trip 7. I don't know what it is. 7.8 maybe? I think, yeah, it's a 7.8. So 7.8's a good example of this with... You can see the engine kind of facing down like this, and it's pretty slight, but you can see the angle is not flush, it's up a little bit. And so part of that is when you're cruising, right, when you're cruising, the nose is up a little bit more, so the engines are in line with the direction you're going, but also the engines are below the center of gravity, right? So the center of gravity is, say, right about there on the wing. And so the engine thrust is below the center of gravity. And let's do red. So the engine thrust is below the center of gravity, right? So it's pushing like this, right? So what's going to happen? It's going to cause your nose to go up. And that's what happens with low-mounted engines in a jet. When you push the thrust up, right, it's causing nose up pitching moment. And it's the opposite in tail-mounted. In tail-mounted, when you push the thrust up, it causes the nose to go down. And so one of the ways you kind of correct for this is by angling up a little bit. As you push the thrust up, it still wants to push the nose up, but it's not as extreme. It's more like that. And so you get less of a pitching moment when you do thrust changes. So that's all the engineering of that, and that's what we're trying to do. So you see this all the time where people are they're flying their helicopters in game with a big heavy container really low below them, and they do something like put on a pusher prop, and then the pusher prop, they start doing front flips, and they're like, oh, this doesn't make any sense, stormworks sucks. It's like, no, this is what would happen in real life if you did this. But they do some interesting engineering to fix those problems, you know, like angle the engines. And so you have to do the same thing in game you do IRL, angle your engines. All right, let me read through chat, and then I got to go. All right, let's see. All right, chat. Where do we end? Right about there. Oh, very nice. Yeah, I haven't done trains in a little while. Yeah, the CB had a lot of CB had a good angle on it. Like, you know, it's very slight too, and you can see like the other one too is like on a Mooney, they actually angle the engine. Let's see, it has right turning tendency, so they actually angle the engine slightly to the left, and that's because it's to fight the right turning tendencies. I can't remember left turning tendencies. I haven't flown single engines in a long time. But it's to fight the turning tendencies. You would put on, you can angle it left and right as well. All right, guys, I appreciate you guys hanging out. That was good to get this worked on. I got a bunch of other things, but I want to get this module done so that hopefully I can build a bunch of helicopters, and I'm trying to redo a bunch of my panels so then, like, you know, this will essentially have my engine control panels for my helicopters. That's what this is going to be. And then it has a coax panel. That's going to be my new coax panel. And then I'm trying to do it more modularly, where if I do one turbine, I just use this one panel, and then these panels will talk to each other. So we'll go seat to panel to the actual overhead panel. And that makes it so that I can more quickly build things and still play, you know. And then having a coax panel, and then this module here is going to be able to go on top of or in line with a bunch of different helicopters, and I'll be able to more quickly make, say, a helicopter. And then all you really need to do to change this up is you put one rotor on here, you shoot out, you put a gearbox, and you shoot out a pipe, and now you've got a conventional helicopter. You know, and so it makes it pretty easy to make things. So if you guys liked the video, give the video a like. If you're new and you enjoyed it, consider subscribing. And I'll see you guys next one. Thanks, guys. See you later.